Let's talk about cookies, tokens, APIs, and let's talk about what that means. So essentially, this talk is inspired by something that I often encounter when I talk to developers. So many developers are building modern web applications, and they should. We're building React, Angular, Angular stuff, Vue or whatever, backed by an API. And it's a great way of doing things, and it's an interesting way of doing things, but it also changes a lot of things. And one of the things that people struggle with is, how do I do session management? Which may even sound very strange in the context of an API, like sessions, that's probably not right. But there's no good word for it, and there's no good definition for it. And this is something that I actually see. And the talk is going to focus on these struggles. Developers see them, and I don't have an answer for developers. I have a set of options, and each option has their pros and cons, and I'm going to lay them out for you. And there's a lot more that plays a role than you might think, because the web is a very complex and a place full of subtleties. So I'm going to talk about that for the next 30 minutes. To make sure that we're absolutely on board of what we're talking about, this is the old way of doing things. This is what you did before when you had a web application, a browser running here, where's my thing? A browser running here, making a request to authenticate to a backend, and you get a cookie in return. Very traditional, the old way of doing things. Whenever you make a call, the browser is going to send that cookie along, the backend makes an authorization decision and decides whether it's good to go or not. The modern way of doing things looks something like this. We still use browsers in most cases, even mobile applications usually have a browser under the hood, but that aside. So we still make the call to authenticate, but instead of a cookie, we get a token. And that token magically appears on the request. Somehow the backend makes authorization decisions and off it goes. From this picture, which is totally marketing on PowerPoint, by the way, but nonetheless, this is not a real architecture, but the differences are not really there. If you split it out a bit, you could derive that in the old way of doing things, we had a server-side session object. So we keep something on the server, we refer to that server-side session object with an ID. That ID we put in a cookie, which is stored in a cookie jar. Modern applications often use some client-side session object. So in a typical setup, something you have very often encountered, this would be a JSON web token stored in something like local storage and sent in the authorization header with a bearer type. This is the setup. The difference between these are subtle. This is not the only setup. This is the two most common things, like the old way nobody likes and the new way, which a lot of developers like. And I'm going to talk about what this means in practice in a second. First, a small word about myself. Jim did a stellar job introducing me. So I'm from Belgium. I did a PhD in web security, and I'd like to think that I have a very broad and very deep understanding of how the things hook together and what influences what. And I can tell you that's a very difficult thing to achieve, and that's what I try to explain to developers. I'm a Google developer expert, which is a recognition by Google, not employment by Google, so I'm very thankful for that. It's for the work I do for the community, teaching, talking, stuff like that. And of course, the SecOutDev course in Belgium, the URL is right there. I highly recommend you to check it out. We have great food at the course as well, and the course itself is very interesting. Since about a year, I left the university where I did work for a couple of years after my PhD, and I started my own company called Pragmatic Web Security. And with that company, the main thing I do is developer training. So I travel the world, I go wherever your developers are, and I teach them about how to build secure software. And I don't teach textbook examples like this is cross-site scripting and that's the fix. I help them to understand the problem. Because in my opinion, the most important thing you can teach a developer is to recognize a problem even in different contexts. So if it doesn't look like the textbook example, if you still know like, whoa, this is a problem because it looks like that, that is when you start achieving real results. All right, enough about me. Let's talk about APIs and cookies and tokens and so on and so on. So one of the first things I want to point out is that your deployment scenario really matters. So if you have an application, you have a couple of clients, you have a few backend services, honestly, if you're building something that looks like this on your architecture diagram, you probably get away with a stateful backend, which is maybe a very unpopular opinion, but I've encountered plenty of developers that have shifted to Angular and started doing some stateless backends, and afterwards, after a couple of months, a year, 2 years, they're like, why did we do that? We only have a few hundred users, and we actually knew how to handle sticky sessions or session replication, and this works quite well. So for most of you, this probably doesn't hold, but for many people, for many internal systems, this actually does work. So if you have a developer that has been doing something for 20 years and knows how to do it well, keep doing it. It actually works really well with other systems as well. However, if you're doing something like this, then you probably might benefit from kind of a stateless backend. It's probably going to be a REST backend, and so on. So we don't need to debate this. I just wanted to point out that the old way of doing things, keeping state on the server, is not necessarily a bad thing. Brings me to the first takeaway. I have a couple of takeaways throughout the presentation. Don't overthink statelessness. Yes, statelessness might be important, and yes, there are different degrees, and I don't advocate to have like a request that changes its results arbitrarily based on some state on the server, but keeping track of authorization state in a server-side session object, there's nothing wrong with that. Yes, it's not a pure REST API, but the company is called Pragmatic Web Security because I don't talk about the purity arguments, I talk about practical things, and this actually does work in practice. All right, back to the old way and the new way. So the old way, cookie header, identifier, you have some random session ID in there pointing to a server-side session object. The new way of doing things is you have the authorization header and you have some kind of a token in there. This is often, this slide represents kind of a frustration for me, a pet peeve. People often talk about cookies versus tokens, which is, they mean this versus this. They mean keeping track of state on the server versus keeping track of it somewhat on the client and using the authorization header to handle that. This comparison makes no sense. And I know people that know that it actually doesn't really make sense, and they keep calling it cookies versus tokens, which creates more confusion than you might think. Because why not put a token in a cookie? Or put an identifier in the authorization header? That gives us two more options, which is pretty awesome. And this is the real problem that many people struggle with. Cookies and tokens are two different things. Cookies are a storage mechanism in the browser and a transport mechanism on HTTP. And the authorization header is also a transport mechanism. And what you put in there is something completely different. Whether you put an identifier or a token or whatever in there, that's a different question. And actually, that's the least challenging part of some of these things. So to make, I saw some people laugh when I presented the other options because they look silly, right? If I present you like, hey, let's put a session ID in a bear, it's like, no man, nobody does that. However, if you're using something like OAuth, you probably are doing that. You maybe don't realize it that you're doing that, but that's essentially what's happening. Let me give you a very quick overview of OAuth. This is I don't know if Daniel Fett is in the room, this is not an accurate representation of OAuth. He did a much better job doing that. I just need a few architectural components to show you one example. So what you want to do with OAuth is the user wants to access a resource here through a client application. So there's something going on. The client is going to do some complicated redirect flow with the browser of the user. This might be an application in the browser. This is just a vanilla page in the browser. So there's going to be some redirect flow, and eventually the user is going to authenticate to the authorization server one way or another and approve the application to access this resource on the behalf of the user. Very broad overview. When that happens, you get an authorization code. We saw that a couple of days ago. The authorization code gets propagated to the client, and the client uses that to request an access token from the authorization server. And this access token, the word says itself, token, this is what the client is going to use to access a protected resource one way or another. This access token represents authority. The resource server is going to use that to make an authorization decision. The resource server is going to look at that token like, who the hell are you? Oh yeah, I know who you are. Yeah, you're allowed to access this resource. Go ahead. And that's what's happening there. There's two ways of doing that in OAuth. This, if it looks like this, then the access token is a self-contained token. And in OAuth terms today, that means it's a JWT, a JSON Web Token, signed by the authorization server, containing a set of claims about who's making this access. This is the traditional, or this is what's common understood under using a token to access a resource. But OAuth has a second mechanism. OAuth supports something called reference tokens. And in a reference token, this token is a random string. It means nothing to the resource server. The resource server instead has to go here with that token and ask like, hey man, I got this from the client, what the hell is this? And the authorization server is like, oh yeah, I know this reference token, I generated that before. It actually represents the data that we have here. So it represents, it's still active, it represents a client, and you can use that to make your authorization decision. And authorization decision happens one step later before the response is returned. And this is a very good illustration of why this whole discussion between cookies and tokens doesn't make sense. You have to distinguish between the mechanism and the value. That's important. And the value can either be, the value represents how you're handling this. This can refer to some server-side state, regardless of where it's kept, or it can be a self-contained token, such as a JSON Web Token containing a set of claims. But how you transport that and how you store that is completely separate from what it actually represents. And in the rest of this talk, I'm not going to talk about what it represents, not about the value, but about the mechanisms, about how you store values in the browser, the implications of that, and how you transport them back to the server. All right. One of the first things we need to talk about is one of the major differences between cookies and the authorization header. So this is how stuff gets transported back. We have two scenarios. Keep in mind, this is not the slide about statefulness and statelessness. This is just clients sending something to the backend with cookies or with an authorization header. Cookies are handled by the browser. The browser does that for you, which is kind of nice in certain cases. So one of the implications of that is because the browser handles them, the browser decides when to send a cookie, and cookies are associated with domains. So if you want to use cookies there, or if you're using cookies there, it only works well if you have your APIs or your backend systems running on one domain. So domain-wide cookies are no longer recommended, and sharing cookies across domains is not a feature that's supported in browsers. You can make it work, but it's very dirty and very hacky, so it's probably not the way to go. If you're using the authorization header, you have flexibility, you have more options. So the authorization header is added by your application. So your Angular application will have a piece of code to add that authorization header to an outgoing request. I'm going to come to that in a second. And because of that, you are flexible. You can do whatever you want. So if you want to send it to different domains, why not? You decide, which is pretty awesome. So that's one of the consequences here. Your deployment scenario of whether you're deploying stuff in one domain or on different domains is going to heavily influence the decision that you're going to make on how to transport this information. If you're using multiple domains, cookies are probably not a good option, and you'll have to deal with the subtleties of the authorization header. Of course, if you really strongly feel about one way or the other, that might again influence your deployment as well. So these things definitely matter. All right, authorization header. Let's talk about that in a bit more detail. Like I said, your Angular or your front-end application, your browser-based application will have to handle whatever you're sending, the ID or token, reference token, self-contained token, whatever you're sending, the application will have to handle that. So you need code to do that. One of the aspects of handling that means storing it somewhere, so that you actually have it when you need to send it. And a common place to put that is local storage. Look at 100 tutorials, 99 or 100 are going to say put in a local storage. What does this mean? Well, local storage is an area in the browser that is isolated per origin. So if you have an origin, https example.com and port 443, that's an origin. That's represented by the orange one here. Code running in the orange context has the orange origin and will be able to access this local storage area. If you have a separate browser window, same browser of course, page from the same origin has access to the same local storage area. If it's another origin, the blue one here, it will not have access to that storage area. It will have access to its own area with its own origin, but not the one from the orange origin. However, if you load frames in here, for example, again, this context has the orange origin, it will be able to access that local storage area. There's a little brother to local storage called session storage. And session storage is a bit more restrictive. So in session storage scenarios, you still have the origin-based separation, but there's a second thing that matters, and that's the window and its children. So essentially this one, the orange one, has access to the session storage area. If it opens a pop-up that, for example, opens in a new tab, that one will have access to the same session storage area. However, if the user opens a completely unrelated browser window, navigates to the site again, that site, even though it has the orange origin, is not related to this set of windows, so it will not have access to session storage there. It will have access to its own session storage area associated with this window and its children. This is one of the common ways of setting things up when storing values. I'm going to give a more detailed comparison in a couple of slides. There's one problem with this image that many people recognize. Like, yeah, this is all fine and it will work, but what if something goes wrong? What if the attacker gets a foothold in one of these pages? This is cross-site scripting. If the attacker gets a foothold, he'll be able to read my local storage, get my whatever token, ship it off somewhere else, and abuse that for all kinds of nefarious purposes. And that's a very true observation. So how do you handle that? Well, don't have cross-site scripting, that's step number one. But I think we saw yesterday, I believe, or 2 days ago, that that's really, really, really hard. So some people are suggesting, yeah, but what if we use cookies for that? Because this cross-site scripting, that's a big problem. So what if we had something that we could use to identify a requester without risking cross-site scripting? And that something is called HTTP-only cookies. And they're not very secure. Because HTTP-only cookies address one specific consequence of a cross-site scripting attack. They hide a value in a cookie from JavaScript. They tell the browser, this cookie should never ever be seen by JavaScript. But wait a second to take a picture, because there's going to be a second line at the bottom that actually matters. But that's HTTP-only cookies. And yes, you can hide them, but the real problem is you still have a cross-site scripting vulnerability. And the attacker can inject whatever script he wants. And yes, maybe a very simple script kiddie-like attacker will not be able to extract that value, but a real attacker will be able to send whatever he wants to the backend, change the DOM, change the behavior of the application, trick the user, whatever you want. With that said, HTTP-only is still useful. It matters. It has very tiny benefits. Yes, Jim, it does. In the PDF of the slides, there's, by the way, an extra slide explaining this in a bit more detail, but it's not useful in an XSS context. That's what I want to say about that. Yes, HTTP only works, well, if you want the details, it works. If you have domain-based cookies, it works against certain attacks. That's one thing that can help. Subdomain-based session hijacking, for example, and it helps against Spectre and Meltdown attacks, where they steal stuff from memory through some, God knows how these things work, but through some complicated attacks. And HTTP only works there if your browser supports it. So Chrome, for example, if a cookie is marked as HTTP only, will not put it into the rendering process. So it's not available in memory in the rendering process, only in the networking process, and because of that, it's somewhat more protected. So it helps, but not in the context of cross-site scripting or stealing stuff from a browsing context. Again, the PDF of the slides is on Twitter. They're going to put it on Sched as well, and there is a slide detailing this in a bit more words. So if you want to compare these things, we have 4 potential storage areas. Local storage, session storage, you can keep it in memory if you want, and you can put it in a cookie. So what does this mean in detail? Well, first of all of them survive page reloads except in memory. So in memory is probably, I'm going to come to that in the next points, but it's probably the most secure way of doing things because you can fully hide things. You can guarantee some security properties there, but if the user hits F5 or Command R or whatever, it's gone. So it's probably not very usable in practice. Local storage is available to the entire origin. Session storage, origin and window and its children. In memory is wherever you want it. You can fully, it's only available to running code. And cookies, if you mark them as HTTP only on outgoing requests. This means that local storage cannot be shielded from malicious code. There's simply no way to do that. If you have access to the script, to the scripting context, if you can run script code, you can read local storage. Session storage is a bit trickier because you need to run the code in the actual window and or one of its children, so it's a bit more constrained. In memory can be shielded. It's very tricky to do that in JavaScript, but if you really want to, you could do that. And cookies can be shielded as well. But none of those prevent abuse in the presence of cross-site scripting. And that's why none of this actually matters if you have cross-site scripting. And the discussion of, yeah, should I put it here or there? Because if an attacker can do an XSS attack, he might be able to read that. Honestly, it doesn't matter. Don't underestimate cross-site scripting. You are screwed if somebody has a foothold in your application. This is important because sometimes you see security guidelines saying, don't put something in local storage. But if it works best, if it saves you time on development, and the only argument is, yeah, but cross-site scripting can read it, I don't think it's a valid argument. All right. So we have all of these options for storage, and it also impacts transport. Let's talk about cookies for a second. Who here likes cookies? Wow, 3 people. I mean the HTTP version, not the chocolate chip. Not too many people. Why not? Well, I'm going to show you why. This is the traditional, very old school set cookie header. Name value. How hard can it be, right? You set it in the browser and browser handles it. Beautiful. Well, no, because you also need a secure flag. to tell the browser, by the way, this cookie should only be sent over HTTPS, which I'm using, of course, so don't send it over HTTP. And then you need the HTTP only flag, like, yeah, I don't need this in JavaScript, please hide it. And then you need a prefix, because hey, turns out that this is not strict enough in browser handling. So you need to tell the browser, by the way, when I say secure, I actually mean secure, so don't do some crazy browser quirks, but actually handle this securely. So you can add a prefix called __secure dash to the name of the cookie. And if any non-Microsoft browser sees this, they will handle this very strictly. They will only accept it over HTTPS, and they will mandate that the secure flag is there. And then you can choose, like, hey, maybe I should replace the secure prefix with a host prefix, which tells the browser, like, by the way, this cookie should only be sent back to the host that has set it. So it eliminates domain-wide cookies. So all of these are why nobody here likes cookies. It's a mess. Let's be honest, it's really messy. And adding stuff to the name of the cookie to make it work, it's not pretty. There's a reason that they did that. We can talk about that offline. It's not pretty, but honestly, if you configure a cookie like the two last ones, depending on your needs, it's actually not too bad. But this requires effort to configure. And if you're using a framework, maybe they don't support this. I don't know many frameworks that don't allow you to configure the name of their cookie that they're using, which is potentially a problem. So this is why everybody hates cookies. So all hail the authorization header. Much better, because you have control, you can do whatever you want. And let's be honest, we all know better, right? As developers, we know better than browser implementers, and we can write better code. So in Angular, this is how you do it. This is Angular JS 1, this is Angular 4+. Very easy, very straightforward, taken live or directly from tutorials on the internet. Like a few meaningful lines of code and you're done. This code will get, in this case, your token from local storage and add this to an outgoing request in the authorization header. Same thing here, it's a bit more structured and there's an authorization service involved, but essentially under the hood it does the same thing. Easy enough, no cookies, no mess, no flags, no whatever. Well, this is what you see in applications. I've seen plenty of Angular applications using code like this. And this works if you contact your API, because the authorization header will be there, and the value from local storage will be there, or session storage, or whatever you want to keep it. But it works too good, because if you contact a third-party API, this thing doesn't care. It's like, oh, I see an outgoing request, bam, authorization header, and off it goes. So if you're fetching something from a third party, from an untrusted party, some static public data, whatever, this code is going to attach an authorization header to every outgoing request. Oops, that's probably not what you want. And this is actually quite common. So what you need to do is, if you implement it like this, you need to have a list of approved origins or domains, and you should send it only there. And some libraries have support for that. So this is Angular, the Angular JOT library from Auth0. They have a property called whitelisted domains where they allow you or require you to specify where your authorization header should be sent to. But if you're writing this code yourself, you'll have to implement that yourself. And implementing that yourself means URL matching. And if you know about web development, URL matching is one of the dirtiest pieces of code you can write and one of the trickiest ones to get right. It's actually not that easy. So the takeaway here is there's no free lunch. Whether you go with cookies or the authorization header, you're going to have to spend a lot of effort on making sure that this is done in a secure way. Whether it's adding flags and prefixes or ensuring that your code has the necessary restrictions in place, you need to do that. And that's just the reality. All right, so far, I don't know whether it's a tie, I didn't keep score, whether it's a tie or not, but let's talk about some of the subtleties of the web. Let's say you're like, you know, screw cookies, I'm doing Angular, I'm going to be very progressive and I'm going to use the authorization header. It makes sense in our scenario, so you start doing that. I've seen that with a customer. They started doing that. And then they said, like, hey, we're going to load some additional resources, like images or script files. And they load that. Very simply. You add an image tag or a script to the DOM, and the browser is going to send out a request to load that. You know what's not there when the browser sends that request? The authorization header. They needed to do authorization checks on loading images and script files, and they had no authorization information because the browser simply doesn't send it. Because your application handles the authorization header. And your code cannot control how this request is sent. Well, that's a lie, but I'm going to come to that in 2 seconds. However, if you're using cookies, the browser sends them, because cookies are controlled by the browser, and the browser will actually see, hey, this is a request to a domain for which I have a cookie, I'm going to send that cookie. The reason I said this is a lie is because today, in some browsers, you can use a service worker to intercept these requests and add a header on the fly, but it's dirty, and I strongly don't recommend doing that. And it's not only images and scripts, it's XHR. If you make an XHR request across origins, you can say with credentials true. This property is about cookies. If you set it to true, the browser, if it has a cookie, will send that cookie on this cross-origin request and will ensure that the server expects it and so on and so on, but that's coarse. Authorization header with bearer, it's not there. So if your application across origins would have to add that, it would have needed, or would need to get that from the application somehow, making it a lot more complicated. And there's a third one. If you open a WebSocket connection, you do WebSocket, new WebSocket, boom, off you go. You know what's not there? The authorization header, but cookies are. Browser knows, I have a cookie for this domain, I'm going to send that cookie along with this request. And believe me, if you're opening WebSocket connections, you probably want to do some authorization there. Some people have tried it without authorization, it didn't end well. So these are some examples of why cookies are actually always there. Cookies are handled by the browser, and because of that, they are sent on every request to that domain originating from the browser, unless you configure the browser not to do that or something. But this is something to realize, that the authorization header is not always there. So if you're depending on these use cases, if you're depending on the authorization there, instead of building a complementary authorization mechanism next to the authorization header, maybe cookies are a better choice. Seriously. Thank you. I think you're a bit too soon, though. Because if cookies are always there, we have to deal with CServe. That's, again, the downside. It's easy to fix. Well, reality would disagree, I think, but SQL injection is also easy to fix, and look where we are today. But yeah, CServe makes most people sad. But maybe in an API world, it's not so bad. But it depends. So I learned over the past few days that you guys all know what CServe is, so I'm not going to explain CServe. I'm going to talk about some solutions. Maybe the first text slide, who knows. If you have an API that's only accessible with XHR, CServe is not that bad of a problem. But you need to make sure that it falls under the restrictions of CORS. And CORS essentially governs how cross-origin requests can be sent from the browser. So if you have an XHR request that uses something that can never originate from an HTML element, such as the content type for application/JSON, nothing can send that except JavaScript. And when you send JavaScript across origins, from the attacker's origin to the backend that you're trying to attack, the origin header will be there, and your CORS policy will decide whether this is allowed or not. So if you have such an API, you essentially only need to make sure, well, only is easy to say, you need to make sure you have a strict CORS policy in place, and then you're good to go. CServe will be handled by that CORS policy. However, if for some reason you have a strange API, which do exist, that accepts HTML-generated content types, form-encoded data or something like that, you're in trouble. Because you will need to handle CServe if you're using cookies. If you're not using cookies, the whole problem goes away.
Do you think double cookie submit is, should we be talking about triple cookie submit, or is double cookie submit enough?
Double cookie submit should be enough. I have no idea what triple cookie submit is.
It's where the variable names are.
Well, we can talk about that later. So double submit cookies are kind of a pattern to eliminate CServe in a transparent way, in the sense that the server doesn't have to keep track of CServe tokens. You push it to the client in a cookie. So what really happens is the client application, let's call it an Angular app, will read that cookie and copy the secret value into a header. And only your application can do it, because only your application runs in your domain. Otherwise, again, you're screwed and CServe doesn't matter. But only your application runs there, can read that cookie, can attach it there. So if it's present, it's legit. If it's not present, probably comes from somewhere else and you don't want to accept that. Kind of implies that this only works within your own domain, and Angular actually supports this pattern out of the box. If you send it a cookie called XSRF token with a dash in between, Angular will automatically copy that into a header on every request it sends, which is pretty cool. However, if you have such an API, you should be aware that it's very hard to secure these things. It's very tricky to get this right, because there's ways that cross-origin requests can be forged. So in a cross-origin setting, this is never going to work in a secure way. The only thing you can do there is to have a strict course-based API, enforce content types, have a strict course policy, and you're good to go. Here's one example of how you can forge cross-origin requests with custom headers. It's Adobe PDF, of course. I have to thank Katowice for pointing me to this specific attack vector. So essentially what you have here is you have a PDF document. And in the PDF document, you can specify some values, and it's a text encoding with some strange characters, and then test. And this will trigger an HTTP request to the backend. And that HTTP request looks like this: a post to a test endpoint. That's the one here. I don't know where the test is, but it's a post with the content type. The car set is the one from here, and then the test header ends up here. So with this technique, you could inject any arbitrary origin header you want. That's why your API needs to enforce content types, because the content type will say it's coming from an Adobe, or it's expecting some Adobe crap. I don't know anything about Adobe PDF, so no idea there. But it actually tells what's happening, but if your API doesn't enforce this, you might be vulnerable here again. So CServe is kind of tricky. So cookies are always there, which is in this case a downside. Because it enables CServe, it requires us to think about CServe and to configure a strict course policy and test that strictness. Test that your API doesn't accept arbitrary content types. Test that it sends the proper course headers on the response, and so on, and so on. All right. Like I said, it's not a simple problem, cookies versus authorization header or whatever. So you might want to get rid of cookies altogether. So let's go back to our authorization header. This actually looks really nice. No cookies, no flags, attributes, CServe, whatever, man. We're going to vet this piece of Angular code and we're good. So we have our access token here, but where does it come from? It comes from the authorization server. We have this authenticate step here, so the authorization server knows who the user is. But if you have an enterprise setup of OAuth, you have SSO. You have single sign-on. So the authorization server, when you go there again and again and again, it knows like, yeah, I know who you are. It's good. You can access your application. And how does it know that? Well, it knows that because it uses cookies. Here, this is a redirect request from the browser to the authorization server. A redirect, you have no control over that. You cannot add additional headers. There's no authorization header there. And the authorization server usually uses a cookie to keep track of a session. So even though you don't have cookies in your application, you're still depending on cookies. And even in a setup where you have a mobile application, if your client is a mobile application using OAuth, it uses the browser on a mobile device to run the OAuth flow. And that browser on the mobile device uses cookies to keep track of authorization state with the authorization server. So this is kind of the last takeaway. Cookies are inherent to the web. There's honestly no way around them. Well, there is, but it's going to take you a massive amount of effort to work around them. And honestly, it's not necessary to do that. Just be aware that they're there, and they're the only thing that's supported by all web technologies. Course is not an old thing from 15 years ago. It's a fairly recent API, and it supports cookies. Because that's the way these things actually do work. All the new directives for doing cross-origin requests and loading all depend on using cookies. So be aware of that. The downside is we need to secure our cookies. Here's some data from Google telemetry. This is, I'm going to say what it is. It's fucking depressing. This is not good. So today, if you look at HTTPS data, we have 70% of page loads happening over HTTPS, meaning that all of the cookies on those requests should be marked as secure. And we're barely at 10%. That is depressing. This is not good. Prefixes have been available for about 2 years. We're in the triple digits here, behind the comma. This is actually not a very good place to be in. And because of that, there's a proposal from MyQuest, from Google, working on Chrome, to get rid of cookies. Like, hey, maybe it's time. We've tried to make it work, and honestly, we can put out whatever we want. Nobody is using that. And it's really hard to convince people to use that. So what if we could have a mechanism that we don't need to patch over and over and over again? What if we can make something that has decent properties by default that people can actually use without having to worry about something that breaks? That we can offer new applications a way to get things done in a better way. And that's what the HTTP state tokens draft spec is about. I'm not going to go into detail here. If you're interested, read it. It's a draft. It's just released like at the beginning of the month. And they're actively looking for feedback. They're actively looking for, will this work for you? How can we improve this? So I highly recommend you take a look and chime in if you have something useful to say. So let me wrap this up in 3 points. First, cookies are part of the web. Whether you like it or not, they are there. And whether your application uses them or not, other applications will. So if you're running your own authorization server, lock down your cookies. I don't know about all commercial products, but I hope they have controls that allow you to do that. And if they don't, harass your vendor until they actually add support for these features. But keep in mind, cookies are not mutually exclusive with APIs, which I have heard some people proclaim, like APIs can never use cookies. Well, honestly, if it's a web-based API, they can. Alternative is the authorization header. Keep in mind that you can put whatever you want in that authorization header. There's no restrictions. They give you more flexibility. It's easy for you to do whatever you want with the authorization header, but you have to write the code and you have to secure the code, which is, again, potentially a downside. And then finally, look at that proposal for HTTP state tokens. It might make your lives easier in the future. It actually has some very interesting controls and has some mechanisms where you can allow or require the browser to sign requests and prevent theft of that token altogether on the client, which is pretty cool. All right, final slide. I've made some security cheat sheets on Angular security and JOT security, so this might be very relevant for you and for the developers in your teams, so you can grab them from the website. The slides are on Twitter, so you can grab them there as well. There's a clickable link, so you don't have to type the whole URL, but these might be interesting. If you have feedback on that, reach out. I'm very easy to reach. Here are my contact details. So follow me on Twitter. I have some interesting security things to say there. If you have feedback, comments, questions, send me an email. And that's it. Thank you. All right, so relying on CORS for CSRF protection seems dangerous. Is it acceptable to use double cookie plus CORS? First of all, well, the question is more elaborate. It says it's dangerous because not all browsers support CORS. What time are you living in? Well, yes, okay, not all browsers may, browsers may not all support CORS, but if a browser doesn't support CORS, it refuses to send an XHR request across origins. Because pre-CORS, if you send an XHR, you can only send it to your own origin and never to a cross origin. The browser would simply refuse to send that. You can test, if you have a Mac, you can easily test it. You can download Firefox 3, it still runs on your Mac OS, which is pretty cool. And you can send a cross-origin request, and Firefox is like, no way. No, I'm not doing that. So if you can send cross-origin XHRs, CORS is implemented. And if CORS is implemented, the origin header is there. And then you can rely on that. But only if you are sure that the request is coming from CORS, from XHR, meaning that it has to be one of the content types that forms cannot support. The question is it acceptable to use double cookie plus CORS? It's kind of a fallacy in a sense that if you are sending CORS, you're sending cross-origin requests, and then the origin sending the request will not be able to read the cookie associated with the backend. So it's probably not going to work because there's no access to the cookie. But whoever asked that, the anonymous guy here or girl, you can talk to me afterwards and I can draw it out and we can discuss that in more detail. All right, thank you. And I'm still here for the rest of the day, so talk to me if you have any questions.